This video is provided as supplementary material for courses taught at Howard Community College. And in this video, I want to do some word problems involving permutations and combinations. So here's the first example. A museum has 7 paintings by Picasso and wants to arrange 3 of them on the same wall. How many ways are there to do this? Well, we've got this word arrange, so that's pretty much of a hint that we're dealing with arrangements or permutations. So we're going to use the NPR formula. So NPR equals n factorial over n minus r, that whole thing, factorial. We're using that because we have 7 paintings, but we only want some of them. So that means we've got to use this formula, which allows us to take just some of the paintings and not all of them. Now, the n is going to stand for the total number of elements in the set we're dealing with. The set is the 7 paintings. So n is the same as 7. So I've got 7 factorial as the numerator of my fraction. And the r is how many elements, how many paintings we're going to have in each of the arrangements. And that's just 3. So n minus r would be 7 minus 3. And 7 minus 3 is 4. So that means I've got 4 factorial as the denominator. Let's see if we can figure this out without the calculator. So 7 factorial, I could rewrite that as 7 times 6 times 5 times 4 times 3 times 2 times 1. And 4 factorial is going to be 4 times 3 times 2 times 1. And for this fraction, I could cancel out the 4's and the 3's and the 2's and the 1's. And I just get 7 times 6 times 5. So we could multiply this out. Let's do the 6 times 5 first. 6 times 5 is 30. I know that 3 times 7 is 21. So 30 times 7 would be 210. So that means there are going to be 210 different 3-painting permutations or 3-painting arrangements that I can make from this total of 7 paintings. Okay? So once again, when you've got some set of objects and you're permuting or arranging just some of them, you're going to use this NPR equals n factorial over n minus r factorial. You're going to use that formula. Okay, let's deal with a different kind of problem. How many ways can you arrange the letters in the word lollipop? So lollipop has a number of repeats in it. Let's count the repeats that we've got. We've got the letter L, and L occurs 1, 2, 3 times. We've got the letter O, that occurs 2 times. We've got I occurs only once. And we've got the letter P occurring 2 times. And there are a total of 1, 2, 3, 4, 5, 6, 7, 8 letters. So for this problem, n is going to equal 8. When we're dealing with arrangements and we've got a repeat of some of the elements, what we do is we take the total number of elements, that's going to be our n, and we get the factorial of that number. That becomes the numerator of a fraction we're dealing with. In the denominator, we take, for each of the elements that repeats, we take the number of times it repeats and we get the factorial of that number. So the L repeats 3 times. That means in the denominator, I want 3 factorial. Then I'm going to multiply that 3 factorial by the number of times that O repeats. O repeats twice. So that's 2. We multiply it by 2 factorial. I repeats once. We could put a 1 factorial in the denominator, but it wouldn't make much sense because 1 factorial is just 1. So we can leave that out. And then P repeats 2 times. So we also want to have 2 factorial as one of the numbers we're multiplying in the denominator. And now we can see what this looks like when we convert all those factorials into multiplications. So 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 3 factorial is 3 times 2 times 1, times 2 factorial is 2 times 1, times 2 factorial again is again 2 times 1. I can cancel out the 3, 2, and 1 from the numerator and the denominator. I've got 2 more 2's left in the denominator. Well, 2 times 2 is 4, and I've got a 4 in the numerator. So I'll cancel out those 2's, I'll cancel out the 4, and what I've got is 8 times 7 times 6 times 5, which you could, I'm too lazy to do it, you could multiply that out either by hand or with a calculator. Or if you wanted to, you could use the factorial function in a calculator and without multiplying anything out, just enter the factorial version of this solution into the calculator and find out what the number is. Okay, so once again, when you're dealing with repeated objects and you want to know how many permutations you have, you take the total number of objects, the factorial of that number, and make that the numerator of your fraction. For the denominator, you multiply the factorials of the length of each of the repeats. So L repeats 3 times, or the size of the repeats. L repeats 3 times, we've got a 3 factorial in the denominator. O repeats twice, we've got a 2 factorial in the denominator. And P repeats twice, so once again we get a 2 factorial. Okay, so that's how you're going to deal with arrangements, permutations, when you've got repeats. And let's do one more. A person playing poker is dealt 52 cards. How many different hands could the player have? Okay, so a deck of cards, we'll assume there's no jokers in this deck. The deck of cards has 52 cards. The player is dealt 5 cards. Now, once the player gets those cards, it doesn't matter what order the cards are in. That player can rearrange those cards any way that he or she wants. So we're going to use the formula for combinations. We'll use that NCR formula, and that's n factorial over r factorial times n minus r factorial. And the n and the r are going to stand for the same things that they stood for in the NPR formula. So n is going to be the total number of objects, that's 52. So n factorial would be 52 factorial. And then we've got r, that's how many objects we're taking for each combination, and that's going to be 5, the 5 cards. So that's going to be 5 factorial. And then I've got n minus r, which is 52 minus 5, and that's factorial. Okay, and once again, probably the easiest thing to do for something like this, because we're going to deal with fairly large numbers, is you could put this into your calculator, 52 factorial divided by 5 factorial times 52 minus 5 factorial, and find out how many different possible hands this person could have gotten. Okay, so I hope this helps. Take care. I'll see you next time.